Alright, so in an effort to be more animated and not so monotone, I'm going to talk in different tones. So, this is section 4.2, using laws of exponents. Can you get excited about this? I think you can. So I hope you have your handout ready, because here we go. Today we are going to look at the law of exponents. There are three parts of the law of exponents, and how do we use them to multiply a polynomial by a monomial. So, here is the law of exponents. There are three laws, and they all require that a and b are real numbers and m and n are positive integers. If that's the case, the first law tells us that a to the m power times a to the n power equals a to the m plus n power. So with the first law, when you multiply exponents with the same base, a is the base, you just add the exponents. So a to the m times a to the n equals a to the m plus n. The second law tells us that if you have a times b quantity to the mth power, you can separate. So you get a to the m times b to the m. In other words, you can distribute the exponent among the two numbers that you're multiplying. So again, the second law, a times b quantity to the mth power equals a to the m times b to the m. The third law says if we take a to the m quantity to the nth power, we get a to the m times n power. So when you have exponents of an exponent, you can multiply the exponents together, and that product becomes the new exponent. So these are the three laws of exponents, and we're going to use them to multiply a polynomial by a monomial. And you'll get used to them right away. Now, there's some mistakes you don't want to make. First of all, the first law, when you multiply exponents of the same base, you do not multiply the exponents together. You add them. And when we get to negative numbers, you will do the same thing. You're not going to add, you're going to subtract. Here are the 6 examples you'll be looking at. I'll go through a couple of them if you want, but if you want to try them on your own, go right ahead. Don't forget to please excuse my dear Aunt Sally. What that means is PEMDAS. Don't forget to do the order of operations in the right sequence. If you don't, your numbers are going to end up all off. Alright, example 1. So we have 5x times 3x times 4x to the 4th. So what you're going to want to do is use the first law. Now when you do the work, you don't have to write all these things down. I'll know what you're trying to do. So what you can do is you can separate the numbers from the x's. So you can multiply 5 times 3 times 4 together and then multiply the x's together. If you multiply 5 times 3 times 4, you get 60. When you multiply the different exponents of x, remember you add the exponents together. So the x becomes x to the first power. So you're adding x to the 1 plus 2 plus 4th power. You are merely adding these exponents together. So what you end up with is 60 times x to the 7th power. So remember the first law, when you multiply numbers with the same base with exponents, you add the exponents together. Alright, let's go on to example 2. We have what you see on the screen. I'm not going to read the whole thing because it's just going to screw you up. So, if you take a look at what we have, remember what we have with PEMDAS, that exponents take precedence over multiplication. So what you have to remember is to not take the exponent of the negative sign. You will rewrite it as so, negative 1r squared. The squared part only affects the r. It does not affect the negative sign. If you wanted something with a negative sign, you would have to write negative r in parentheses and square the whole thing. That would tell you to square both the negative and the r. But in this case, all you're doing is doing negative 1 times r squared. Now, you apply the first law, and you get negative times r squared, r to the 4th. You add the exponents together, and your answer is negative r to the 2 plus 4th power, which is negative r to the 6th. So remember, when you see an exponent over a variable with a negative sign, that the negative sign is like taking a negative 1 and multiplying it by the variable, such that you do not take the exponent of r in this case. So the answer is negative r to the 6th. If you got r to the 6th, you need to go back and make sure you do not take the exponent of the negative sign. Example 3. 3x squared yz cubed all squared. So you're going to apply the second law. You can distribute the exponents. So it's the same as 3 squared x squared squared y squared times z cubed squared. Now you apply the third law by taking exponents of exponents. And when you do that, make sure you remember that that's when you multiply exponents. So 3 squared is 9. X squared is x to the fourth because 2 times 2 is 4. Y squared is y squared. Z cubed squared is the same as z to the 3 times 2 power, or z to the 6th. So when you take exponents of exponents, that's when you multiply exponents. If you are taking an exponent and multiplying it by a number of the same base, that's when you add them. Make sure you do not make that mistake. All right, we're over halfway home now, and I've been asked to give a shout out to people, but then I realized, I want to use these videos next year, and they won't know who half of you are, and I don't plan on any of you repeating this class. And if you do, well, you can sit in the front next year. Example 4, c to the x power times c to the 5 minus x power. Now, we have exponents of the same base. So what you want to do is to apply the first law. Now, when we do the examples, I want to encourage you to try to do these on your own and then hit play and watch what happens with the solution, but you can learn however you learn best. So by applying the first law, remember, with the common base of c, we add the two exponents together. So it's x plus the quantity 5 minus x. That's pretty simple. C to the x plus 5 minus x, the x's cancel, and you're left with c to the 5th power. So remember, when you multiply exponents of the same base, you add the exponents together, don't multiply them. Just because there's an x or some other letter in the exponent, don't let that throw you off. It's just like any other number. When you're adding them together, you combine like terms. Here the x's cancel each other out. Example 5, 6y squared times the quantity y squared plus y minus 2. You might imagine that you have to use the distributive property, and you'd be right. So let's distribute the 6y squared to each term. 6y squared times y squared plus 6y squared y plus 6y squared times negative 2. And now you're going to apply the first law to the first and second terms. Y squared times y squared is just adding the exponents together. Same with the y squared times the y. And of course there's no y in the third term, so you just distribute the negative 2. So you end up with 6y to the fourth plus 6y cubed minus 12y squared. So remember, when you, again, multiply numbers with the same, multiply exponents with the same base, you add the exponents together. Finally, example 6, a to the x minus 4th power times the quantity a to the x plus 2, quantity squared. So what you want to do, just like in some of the problems you worked on in 4.1, you want to work from the inside out. Do the parentheses first, do the exponents next, and then multiply. So you're going to first apply the third law to the right term. You're going to take the square of whatever is in the parentheses. And remember, when you take an exponent of an exponent, you multiply the two exponents together. So the left term stays a to the x minus 4 for now. The right term becomes 2 times the quantity x plus 2. So this term ends up looking like a to the 2 times the quantity x plus 2 power. Now you distribute the 2, and that's what you get. Now again, you are multiplying exponents with the same base, the base of a. So what you're going to do is add the exponents together under the first law. So a to the x minus 4 plus the quantity 2x plus 4, and just like in Algebra 1, you add like terms together. The 4's cancel out, and you end up with a to the 3x power. So that ends this notes session for section 4.2. Again, if you have any questions, please bring them up in class the next day when we meet, and you will get the problems to work on in class. If you have any questions before then, feel free to email me or leave a comment on the Facebook page.